Hi students, today we are learning the topic is Gauss central difference formula. So already we discussing the previous lectures Newton's forward interpolating polynomial formula and Newton's backward interpolating polynomial and formula. Okay, now this is third one, Gauss central difference formula and a direct formula you are finding here. So again Gauss central again two types. So see that here how to finding the Gauss central difference formula to finding the value of the given table values. So that is equal to here two types are given. The first one is Gauss forward interpolating formula. Second one is Gauss backward interpolating formula. And a Gauss central means we have to choosing the point is central point. So above is the backward, down is the forward. So that is you have to finding two formulas here, forward formula and backward formula in the Gauss. Okay na? So how to finding in this one, first we have to see that the formulas Gauss forward and Gauss backward. Okay. So first of all, Gauss forward interpolating formula. So let HP is the step length. There is a step length means the values of the consecutive value of the x is must be same. Step length between successive arguments. You have to choosing here. Y0 is the first midpoint. Next value y1, y2 up to so on. Next backward values y minus 1, y minus 2 up to so on. So assumption y0 is the central point. So of the function at the point. So similarly the x values is x0. It is a midpoint assumption. Okay, na? In the values table values low x0 y0 is the mid value. So remaining x1 x2 is the forward, x minus 1 x minus 2 is the backward value assumption. Okay, na? So formula is given by Gauss forward interpolating formula is given by, so that is equal to here. So y of xp, p of xp, there is no finding the polynomial. We are finding only formula. We have to finding the function value by using the Gauss forward and backward interpolating formula. Okay, we have to finding y of xp, that is p of xp, that is equal to y0 plus p into delta y 1 by 2 plus p into p minus 1 by 2 factorial into delta square y0 plus p into p minus 1 into p plus 1 by 3 factorial delta cube y 1 by 2 plus up to so on. This is a formula for finding the value only. So where p is equal to same, where xp is the point near to x0 and the mid value. Xp is the near to mid x0, mid value x0, and p is equal same formula xp minus x0 by h. So you are finding delta y0, delta square y0, delta y1 by 2. How to finding? We will see the table. Okay, na? So similarly, this is the forward interpolating formula. So next Gauss backward interpolating formula. Okay, na? The same arguments, that is the x values and y values, the same of the unknown function y is equal to f of x. The formula is given by, backward formula is given by, so y of xp, p of xp is equal to y0, p into delta y minus 1 by 2. You can observe chain, delta y 1 by 2, here delta y minus 1 by 2 plus p into p plus 1 by 2 factorial. P into p minus 1 first, p into p plus 1 into delta square y0 plus next p into p plus 1 into p minus 1 by 3 factorial delta cube y minus 1 by 2. Y 1 by 2 delta y delta square y0 delta power 4 y0 delta y 1 by 2 delta y square delta cube y 1 by 2. But here choosing the minus, observe chain minus 1 by 2 minus 1 by 2. Okay, na? So that is equal same here, where xp is the point is near to x0, same p is equal to xp minus x0 by h. Okay, now this is a Gauss backward interpolating formula. Okay, see the table how to finding the values, that is delta y naught, delta y 1 by 2, delta square y 1 by 2, delta y minus 1 by 2, delta cube y minus 1 by 2, up to so on, how to finding using the table. This is important table. See the, so this is the x values assumption, and so this is a center point. So we have, for example, only we have to choosing only 5 values, okay na, only just simplification, that is only easily for finding the up to 5 values. Next to y values, so y naught, y1, y2, y minus 1, y minus 2. So this is a central point assumption, and this is the backward values, this is the forward values, and okay na, observing all of. So next, first order is central value delta y is the first order difference. So difference same and no change, Newton's forward, Newton's backward, yes central. So finding the table is the same, no change, but denoting is the different. So this is the value is this value minus this value is equal to this value, and okay na, this value minus this value is equal to this one. Next this value is equal to this value is equal to, next this value minus this value, okay na, same difference same and no change. Next to second order is equal to this difference, this value minus this value minus this value, next this value minus this value. Next to third order means this value minus this value minus this value. Next to fourth order, this value minus this value, okay na, totally 5 values for fourth order up to, okay na. So next assumption here, backward values, forward values, how to choosing. చూడండి, y naught delta y minus 1 by 2, okay, చూడండి first value y naught choosing, next value delta y minus 1 by 2 value. This is Gauss backward interpolating formula for choosing the values, అండి మనకు ఫార్ములా ఇన్ ద ఫార్ములాలో మనకు వాల్యూస్ యూజ్ అవుతాయి కదా, ఇది y naught delta y minus 1 by 2, next delta square y naught, next one this one delta cube y minus 1 by 2, next one delta power 4 y naught. This is the backward values, అండి okay na. The substituting the formula, this is the backward value choosing the table. So similarly Gauss forward interpolating formula for choosing the values. Next same y naught, next delta y 1 by 2, this is a Gauss forward interpolating formula. Next one delta square y naught, next one delta cube y 1 by 2, next one delta power 4 y naught. So this is the backward values, this is the forward values, okay na. So this is the central difference table. So next one, so next Stirling formula. So Stirling formula is nothing but average of Gauss forward interpolating formula and Gauss backward interpolating formula, రెండింటికి యావరేజ్ వచ్చే వాల్యూ స్టిల్లింగ్ ఫార్ములా అండి, ఓకేనా. దట్ ఈజ్ ఈక్వల్ టు, దిస్ ఈజ్ ద Gauss forward interpolating formula, already told. Next one backward interpolating formula, then Stirling formula is equal to average of two values, Gauss forward plus Gauss backward by 2, that is average only. So adding both we getting the formula here, phi of xp, p of xp is equal to average y naught plus y naught by 2, ఏమొస్తుంది y naught, ఇక్కడ సేమ్ p కామన్ delta y 1 by 2 by delta y minus 1 by 2 by 2. Similarly this is average, next this is average both plus up to so on. This is the Stirling formula అండి, ఓకేనా. average of the two formulas. So similarly we have to choosing, so assumption this value is equal to mu, and this is equal to same, this is equal to this value, this one, up to so on. So both are same formula. Okay, this is a Stirling formula. This is average, and both it average assumption mu of delta y naught. This is average mu delta cube y naught. Okay. See the next one. That is using this one, mu of f of x is equal to average of two values, f of x plus h by 2 plus f of x minus h by 2. Okay. So next one. See the example. So from the following table find f of 38. F of 38 we have to finding the function value by using Gauss forward formula and Gauss backward formula. So using any formula we getting the value same, and maximum same, nearly same. There is a 1-2 points are different, but both are same answer we will get using the two formulas. Okay na. So here given x values and f of x is the y values. Okay na. First to finding the table, central difference table. So that is equal to here, this is x values, x assumption this is the central point x naught. This is x minus 1, x minus 2. This is the x1, x2. Totally 5 values up to 4th order. Next y values, f of x. So assumption this is the y naught, central point. This is y minus 1, y minus 2, y1, y2. Okay. So first order central difference delta y. So delta y is equal to 14.9 minus 15.9 is equal to minus 1. Next to 14.1 minus 14.9 is equal to minus 0.8. Next to 13.3 minus 14.1 is equal to minus 0.8. So 12.5 minus 13.3 minus 0.8. So next second order central. So that is minus 0.8 minus of minus 1, 0.2 minus 8.8 minus of minus 0.8, 0 minus 8 point minus of minus 0.8, 0. Next to third order 0 point minus 0.2, that is minus 0.2, 0 minus 0 minus 0. Next to fourth order 0 minus of minus 0.2. Okay, this is the centered table. Now choosing the values. So forward values, backward values here. Children, this is a central point. So there is now using the backward values is. So this is the backward value. First y naught. Next one, this is delta y minus 1 by 2. Next one, this is delta square y naught. Next one, this is delta cube y minus 1 by 2. Next one, this is delta power 4 y naught. This is the backward values. And next to forward values y naught. Next to delta y 1 by 2. Next to delta square y naught. Next one, delta cube y 1 by 2. Next to delta power 4 y naught. This is a backward value and forward values. Okay. We write all values from the table. So that is equal to, we have to finding y of 38 means f of 38 function value. xp is equal to 38 element, which is near to center point 40. So from the table all values we write. Already I told, already all values write down. This is the values. Okay na? So next here finding value is assumption let xp is equal 38. X naught is equal, which is near to center point x naught here. And h is equal to step length of x values 5. So p is equal to here xp minus x naught is equal to xp is equal 38 minus 40 by 5, that is minus 0.4. Yeah, first using Gauss forward formula. సో గాస్ ఫార్వర్డ్ ఫార్ములా అప్ టు చూసింగ్ ఫోర్త్ ఆర్డర్ కదా మన గాస్ని. దిస్ ఈజ్ ద ఫార్ములా అండి. దిస్ ఈజ్ ద గాస్ సెంట్రల్ ఫార్వర్డ్ ఫార్ములా. ఓకేనా. ఆల్ వాల్యూస్ సబ్స్టిట్యూటింగ్ ఇయర్. All values substituting here, we have to finding y of 38 that is near to y of 38, that is equal to all values. Already here given the values from the table, substituting in this formula we have to finding the values. Simplification is, so next simplification, that is equal to 14.413828 approximation. This is the using the Gauss forward formula. Similarly we have to finding this using backward formula. Okay na. So that is equal to, so backward formula, so this is the backward formula already told in the previous slide. Substituting all values here, y naught delta y minus 1 by 2 up to so on up to fourth order work. So simplification, y of 38 is equal to all values substituting. Simplification is, so that is equal to here 14.4138. Observing here, using the forward formula and using the backward formula, we getting the same answer, no change. Okay na. Can using any formula we have to getting the same answer. So this is the Gauss forward and backward formulas. Okay. So next one, next formula, next example, using Stirling formula to find y of 28 given that. So here given values and y of 20 is equal to 49 to 25 means here bracket in the bracket is x values and this is the y values. Using the Stirling formula, what is the Stirling formula? Average of Gauss forward and Gauss backward. Already formula is single formula, we have to choosing, we have to finding that value. Okay now, using the Stirling formula. So that is equal to central difference table here, same table to finding the both. So this is the x values 20, 25, 30, 35, 40. This is the x naught central point. So in case manaki x values or y values are given evenly ఇచ్చాను అనుకోండి, ఇక్కడ how to say central point we have to finding getting, but in case evenly ఇచ్చాను అనుకోండి we cannot finding the central point, there is no central point here. We can choose any central point, your choice. In the middle లో ఏది ఉంటే తీసుకోండి, no problem. సో ఆడ్ నెంబర్స్ ఇచ్చినా ఈవెన్ నెంబర్స్ ఇచ్చినా మిడిల్లో ఏది మీకు తీసుకోవాలనుకుంటే తీసుకోండి. ఓకేనా. సో దిస్ ఇస్ ద y values, this is x naught, this is x minus 1, x minus 2, x1, x2. Next y values, this is the central point y naught, this is y minus 1, y minus 2, y1, y2. Okay. Now first finding the first order, this is the first order delta y. So this minus this one is equal to minus 901 and this minus this one minus 1080 and this minus this one is equal to minus 1310 and this minus this one is equal to minus 1620. Next to second order, this minus this one is equal to minus 171, this minus this one is equal to minus 230 and this minus this one minus 310. Next third order, minus 230 minus 171 is equal to minus 59, minus 310 minus of minus 230 is equal to minus 80, that is equal to minus 80 minus of 15 minus 21. Okay na. So this is the table. Now we have to choosing the values. So this is the backward values. Avuna. Y naught, this is a delta y y1 minus 1 by 2 కదా, delta y minus 1 by 2. Next to delta square y naught, next to delta cube y minus 1 by 2, next to delta power 4 y naught. Next to forward values, this is y naught, This is a delta delta y 1 by 2, next to delta square y naught, next delta cube y 1 by 2, next to delta power 4 y naught. This is the table. Okay, we have to write the all values. So to find y of 28 and xp is equal to here 28, y of xp is equal to 28, this is the near to x naught. From the table already write the form values, all values from the table already told in the previous slide. That is equal to here xp is equal to 28, which is near to central point 30, and the step length of each x value is 5 difference. So h is equal to 5. P is equal, we have to finding xp minus x naught by h, 28 minus 30 by 5, that is equal to minus 0.4. Okay, now using the Stirling formula. So this is the Stirling formula, average of the Gauss forward and backward, that is equal to y naught plus p into delta y 1 by 2 plus delta y minus 1 by 2 by 2 plus p square into 2 factorial delta square y naught plus up to so on up to 4th order you have to choosing. This the above values all substituting here after simplification is okay y 28 p of 28 is equal to all values substituting here. Yeah, simplification is, and first simplification, next the last simplification is 691.82. this is the value of y of 28 or p of 28, 47,691.82. this is the approximation value. This is the Stirling formula using. Okay, this is Gauss central formulas. Yeah, thank you. For more videos, please do subscribe my channel, like and share it. Thank you.